So when you're writing your first program, two things are vitally important. That is variables and functions. Basically, that is because no C++ program can exist without a function. But let's just start at the beginning first. Any program is going to need variables. In C++, if I want to use a variable, I have to do something that is called declaring it. Now, declaring a variable just tells the compiler to reserve memory for it. And we can give the thing a name because we're going to have to reference the variable and we want to store data in it. So the way we do that is we start by typing a type. In this case, I'm just using int as an example. But there are other types, right? I could have used the type float. I could have used the type double. I could have used the type character. I could have used the type boolean or bool. Now, what is the use of these types? Because in a way, it is restricting what I can store in the variable that I'm going to use. Now, why would I want to do that? The only reason why we give types to variables is to allow the compiler to catch mistakes that we make before we actually run the software. So during this compile time, we allow the compiler to check whether or not we are adding the wrong types. I mean, can I add a variable of type boolean to a variable of type int? What would be the type? What would be the result? No, it's undefined. So if we did this, the compiler would say, hey, you cannot add a variable of type boolean to a variable of type int and expect to have it some sort of sensible results. So adding types to variables is the compiler's way of do compile time checking for our errors. So here we are choosing a type int, and I'm naming my variable, and I'm just going to call it x. And every statement that I make in C++ has to end with a semicolon. I can add another one. I can add an int y. I can't add another int x because that would make no sense. Now I have two variables with the same name, so each variable has to have a unique name. Also, but we'll get into that later, there are some naming conventions. Some names are reserved words. For instance, I cannot make a variable called int. Int, that's going to cause a problem. It's just going to recognize it as two types and not a variable name. I can add a letter to it, and then it'll say, okay, this is a variable name called inta. What I can also do, if I'm declaring several ints, I can also add a comma and then a y. And then I have declared two integers. So this will work. I can add a float, f1, f2, and I can do as many as I like. So these are declarations. It doesn't do anything other than giving the variable a name, reserving memory space for it, and that's it. Now, if I want to add some values, I'm going to have to first assign some values to these variables, because right now I just have a memory space and I have a name, but nothing tells me that there's a value in those variables that makes any sense. I haven't said anything, so what does the compiler do? Does it make them 0? I don't know. It might not. So what I can do is I can assign a value. I can say x equals 5. So this will store the value 5 in my variable x. That's great. X being an int, in this case, I know because I'm on an Intel computer, this int will take 4 bytes in memory, and I also know not by heart, but what the value is, but there is a maximum value that it can hold. So 5, we're safe. But I have to realize, if I'm going to start counting things, if I'm going to make a program that counts stuff, I have to realize that there's a maximum value to this int. So x is 5. And I can also say y is 4. If I said x is 7 right here, x would now hold 7 and the 5 would have been thrown away, right? So this is, I can do multiple assignments. It's just up to me to make it make sense. But I guess that's programming. I can also add. I can say x equals 1 plus 4. X will be 5 now. This operator realizes there are 2 integers on each side, and it knows what to do with adding integers. And the result will be assigned to x. Easy. What I could also do is introduce another variable, say z, and say z is x plus y. So now I'm not adding integers, I'm adding variables. Now note that all of these 3 variables are all ints, so the compiler won't tell me that I can't do that. But if I change this x into f1 plus y, what will be the outcome? I have a float and I add an int. What will the result be? The result will be a float, probably. But z is an int, so the compiler is probably going to complain, or at least warn me about that I'm going to lose data, probably. So these are some of the basics about variables. We've seen declarations. We have to declare a variable before we can use it, right? So I cannot say k is 3 and then say int k below here. It'll come across this and say, hey, you haven't declared k yet. So I can't do that after the fact. I can do it here. I can say int k here. And I'll remove this. And this will be fine. Even though there are statements before it, declarations don't have to appear all at the start of our program. Now, these types, int and float and character and all that, they are all built-in types. They are types built into the language. Later on, we'll see that we can add our own types. You can add user-defined types. And they can be anything that we like. They can represent any object that we detect in the world and we want to describe in a program. The question then will be, of course, how do we add those? How do we multiply those? How do we do those things? Well, luckily in C++, we can make our own operators. But we'll get to all of that. But once we start defining our own types, we will want to also describe what happens when we do operations on them, right? Naturally, besides adding, we can multiply, we can subtract, we can divide, we can do modulo, which is the remainder after division. So there's a bunch of built-in operators. There's one special operator that I guess that we can show here. And I'm just going to remove this stuff. Suppose we had x be 5. And suppose we wanted to increase it by 1. And you probably know where I'm going with this. I could do x equals x plus 1. That will increase x by 1. But there is a special operator in C, it was already there in C, that does the same thing. And it comes in two forms. I'm going to show this one first. It looks like this. X++. This will increase X by 1 of whatever the type is, right? We're talking about integers, so it's just 1. And you can see if I had a an integer C, you would kind of see where C++ got its name from. Now, as we will see later, this operator is a postfix operator, which means it comes after the variable. You can also write it like this. It has a different effect, but forget about that now. We'll get to that later. But I just thought I'd show you this one, just because of the name. Now, can we make this into a program? It looks like a program, but is it? Well, the answer is no, because in C++, every program has to exist inside a function. Now, functions are equivalent to subroutines or a piece of code that you park somewhere and that you can call by its name. This is handy because imagine that you have a certain task in your code. Say you're writing a game and you want to write something to the screen. There's a little routine that writes one character to the screen. Now, you don't want to type that code every time you write a character to the screen. You want to call a function that does that. And it has a name, and you give it something, and it does that. That way, you only have the code once, but you can call it multiple times from wherever in your code you need it. So that's the basics of functions. And in C++, every program must exist inside a function that is called main. And the way we write that is this way. I'm just going to type it out. Like that. Now, you'll see me typing this, and the editor has made sense of it, obviously, because I've lost the squiggly lines and it's formatted my code. But this is what a function looks like. First of all, a function has a name. In this case, it's main, and it has to be called main. It's no coincidence that this function is called main. And the code that we just typed now exists within these curly braces. This is called a scope. So all these variables that I've declared here, they all exist inside the scope of these two curly braces. Now, when I call a function, it has a name, but it can also have parameters. Parameters are variables that I pass to a function so that it can do what I want it to do. And I'll give a small demonstration of that. And at the end of the function, when the function is done, we want to give a result back to the one who called us. So to do that, I can say return. And I have to return what? Well, I have to return an integer. Any integer. I'm just going to return 0 here. And the value that is returned has a type, and that type is the int that I typed in here. So suppose we had some code that did a lot of adding of values together. So this C is C+1 and C++. I want to do that differently. I want to call a function that does that. C equals add value, and I'm going to give it C, and I'm going to give it 7. And it ends here. Now, it doesn't make much sense to write this because I can just add 5 to 7, but it's about the example of functions. So I have to declare now a function that takes 2 parameters, c and 7, both ints, and returns its sum. Well, we should be able to write that now. So if I type in this int add value, because I want the function add value to return an integer, and it's going to take 2 parameters, parameter c and parameter value. I want to make sure that is an int as well. So now I want to immediately return. And what do I return? Well, I don't have access to c within this function. All I have is these pc and pv. So I want to return pc plus pv. Now, this will do exactly what I want, right? I pass 2 parameters here, c and 7. They will be put into these variables, which only live inside the function. They will be added together here and then returned to us as an int value. And since I'm assigning the value that comes out of the add value function to c, we will have our result. So there's not much difference between a function that we define here and the main function. It's basically exactly the same, but we have to have one of these main functions. Now there's one last word about initialization that I want to show you. As I said, we declare some values, some variables here, and we assign some values to the variables. But there's something else we can do. We can initialize variables here as well. See, so this is not just a declaration, it is also an initialization. And I could have written this in any way. I could have ended the statement here and said int x is 4, and then ended the statement here and said int. So it doesn't really matter how I distribute these, as long as it's correct according to the rules. But the fact that I can initialize a variable as I declare it, that is quite important to remember. So that's just a little primer about variables and functions. I hope this has cleared things up. And I would like to see you in the next video. Bye-bye.